Dear students, very good afternoon. I am Dr. Deepasan, but today we are going to discuss about total derivatives. Total derivatives. It is used for the differentiation of implicit functions. Differentiation of implicit functions. So what does it mean, implicit function? First we want to know what is mean by total derivative and what is mean by implicit function. So first let us discuss about total derivative. Already we had discussed about if u equal to f of x comma y, then we can find dou u by dou x and dou u by dou y. Also we can find dou square u by dou x square, dou square u by dou y square, dou square u or dou square u divided by dou x dou y and dou square u divided by dou y dou x in such a way that dou square u by dou x dou y equal to dou square u by dou y dou x under some certain conditions, and we have also discussed an example for that. Now here in total derivative also we are having u as the function of x and y, but in partial derivative we have only u which is a function of two variables. These two variables are independent variables, but here we are having x is not a variable, y is not a variable. There in partial derivative x and y are variables. Here x and y are not variables. Here x and y are also functions. So where x equal to phi of t, and y equal to psi. Okay, y equal to psi of t. X equal to phi of t and y equal to psi of t. Then we can express u as a function of t alone. U as a function of t alone. Okay, so this is the important definition for total derivative. So after this we have found that u is a function of t alone. So by substituting the values of x and y in f of x comma y, thus we can find the ordinary derivative du by dt, which is called the total derivative, of u to distinguish it from the partial derivatives partial derivatives dou u by dou x and dou u by dou y. Okay. So here I would like to mention in partial derivative u is the function of f of x comma y. So with this the partial differentiation is over, whereas in total derivative we have u as the function of x comma y. In this x is the function of phi of t, that is function of t. Y is the function of psi of t. So what does it mean? It means here, since u is a function of two independent variables, we can find dou u by dou x, dou u by dou y. Here we can find dou u by dou x, dou u by dou y, and dx by dt and dy by dt, because x is a function of t alone, y is a function of t alone. So here it is a function of x comma y. So it may be, for example, it may be some x square minus y square. For example, it may be some x square minus y square. Whereas this x is a function of phi of t, means it may be some e power t, it may be some log t. Okay, so it is two different functions. Both are e power t is a function of t, log t is a function of t, but it is exponential function, it is logarithmic function. So I, for example, only mentioning it is exponential, it is logarithmic. So sometimes of the same kind also come, here as x power t, here as y power t. Okay, then both are functions of t. Here x power t, here y power t. Here x power t, here 2t. Whatever it is, both are two different forms, but they are functions of t. On such cases, since x is a function of t alone and y is a function of t alone, we do not do partial differentiation of x and y. Okay, we do the ordinary differentiation of x and y, whereas for u we will do again the partial differentiation, since u is the function of x and y. Okay, so here one dependent variable and two independent variables, whereas for x and y, for one independent variable, for one dependent variable there is one independent variable, for one dependent variable there is one independent variable. So this is the main difference between partial derivative and total derivative Okay, now upload this. Now to find du by dt. Why we want to find this du by dt? Means I shall explain you a few things. After this sentence I shall explain you few things. After that you will definitely understand why we want to find this du by dt. So now to find du by dt, that is by without actually substituting the values of x and y, values of x and y in values of x and y in f of x comma y, in f of x comma y, we define the following formula. We define the following formula, that is du by dt. So now I shall explain you why we want to find du by dt. Suppose first I am inside taking u, okay, inside taking u for partial derivative. I am defining this u as the function of two variables x and y. So now u is the function of two variables. So since u is the function of two variables, it is not possible to use ordinary derivative d, ordinary differential operator d. So we are using dou u by dou x and dou u by dou y. Okay, after this x is the function of t, that is we had mentioned here. So this x is and this x and y are also functions of t. See, x is the function of t and y is the function of t. So I am just writing t here. So this x is the function of t. In the same way, y is also the function of t. Y is also the function of t. In such a case, here since x is a function of one variable, here we can write dx by dt. Since y is a function of one variable, here we can write ordinary derivative dy by dt. So this du by dt means how to reach u to t, how to reach u to t. Okay, so that is what we are going to discuss here. So du by dt means, so we are just by this way plus this way we can reach du by dt, that is equal to dou u by dou x into dou u by dou x into dx by dt plus dou u by dou y into dy by dt, okay. So this is very important formula. This is very important formula. We are having some more formulas also. Similar to this type. So first you have to get thorough with this formula, and after that we shall explain that if t instead of t, if I am having x, what will be the formula. Okay, that is one case. And for three variables, if u is the function of three variables f of x, y, z, what will be the formula. So how to prove du by dx equal to dou u by dou x plus dou u by dou y into dy by dx. So how to prove that formula? So we are going to discuss all those things in our upcoming class. Dear students, kindly go through the following video, and this video will be very useful for you and very important for you to understand total derivatives. Thank you all for watching this video. Okay.